In this video, we're going to review the distance formula. Let's take a look now at the distance formula, starting with Pythagoras, which is of course the Pythagorean theorem. So just to recall, hopefully we all know the Pythagorean theorem says in a right triangle, then we can take the leg squared plus the leg squared, and the sum of those should equal the hypotenuse squared. So when I'm talking about legs, I'm talking about the two that make up the right angle. So on our figure, we could say this is A, this is B, this is C. So what we want to do is, first of all, we can very easily find the length of A and B to find the length of C. So on our figure, I can just count 1, 2, 3, 4, and I can count that because it's directly on my grid line. So A would be 4 squared, and B would be 1, 2, 3, so we're going to take 3 squared, and that's going to equal C squared. So 16 plus 9 is C squared, that's 25 is C squared, and of course that means if I take the square root of each side, I get 5 equals C. So I can say that on my figure, this is 4, this is 3, and this is 5. But the question is, how can we do that without having to draw the triangle? What if I just had the point 2, 7 and 5, 3? So let's think about where these values came from. So if I wanted to find the value of 4, essentially what I did was take 7 minus 3. So 4 was 7 minus 3, which was essentially the y value minus the y value. And if I wanted to find 3, I basically took 5 minus 2. So 3 was 5 minus 2, which was just subtracting the x values. And I actually did this one in the opposite order. This was actually x2 minus x1 to make it positive. But what we can see is using the same idea that we have from the Pythagorean theorem, which we're all very familiar with, we can just replace it with finding the difference of the y values and finding the difference of the x values. And it doesn't matter the order in which we subtract because we're going to end up squaring it, which is going to make it positive. So then, of course, we would take the square root at the end, just as we did in our example. So this is the distance formula, and we can use that distance formula without having to draw the triangle and use the Pythagorean theorem. We can just go straight to the distance formula. Let's take a look at another question involving the distance formula. And this question basically asks, is this a right triangle? Yes or no? And we could say, well, it sure looks like one, but we can't know for sure without, of course, verifying it mathematically. So what I want to do is I want to find the distance of each leg or each side of this triangle. So I'm going to call A, B, and C the 3 sides. So I'm assuming I'm trying to determine, is A squared plus B squared going to equal C squared? Because that would tell me that it is in fact a right triangle. So do I know the length of A? No, I don't. So I'm going to find the distance of A. And again, we're going to use the distance formula. So for the distance of A, I have to subtract the x value. So I'm going to take 5 minus 1, quantity squared, and then I'm going to subtract the y value. So 8 minus 0, quantity squared, which is the square root of 5 minus 1 is 4, 4 squared. 8 minus 0 is, 8 squared. So that gives me the square root of 16 plus 64. So that is the square root of 80. Now, could I reduce that? Yes, I could. Would I turn it into a decimal? No, I wouldn't. For now, I'm going to leave this just like that. Now I'm going to do the same for B. So the distance of B, and B is 1 minus 5, quantity squared, plus 0 minus negative 2, quantity squared. And that gives me the square root of negative 4 squared plus 2 squared. And that gives me the square root of 16 plus 4. So that is the square root of 20. And again, I could write this as 2 square root of 5. And if you don't know how to do that, that's okay. We'll be working on that. But for now, I'm just going to leave it as radical 20. And now for our last one, I'm looking at the distance of C. Now, could I use the distance formula? Sure. But if you'll notice, it's right on a grid line, so I can just count if I want to. Essentially, I'm going from 8 to negative 2, so that's a distance of 10. So feel free to verify that with the distance formula, but I would just end up with the square root of 10 squared, which is 10. So have I answered the question? No, I have not. I've just done all of the work that leads up to answering the question. So now the question says, are these vertices of a right triangle? If it's a right triangle, it will work with the Pythagorean theorem. A squared plus b squared equals c squared. So a, we decided, was radical 80. So I'm taking radical 80 squared. B was radical 20 squared, and c was 10, so 10 squared. Now, what is the square root of 80 squared? Well, the square root and the squared cancel, so this is just 80. Radical 20 squared, again, those two will cancel, and it's just going to be 20. And then 10 squared, as we know, is 100. So 80 plus 20 is 100. 100 equals 100. Therefore, I have verified that triangle ABC is, in fact, a right triangle.